All right, here's the review. Need to know skill number 9. All right, so skill number 9 deals with functions and rate of change. Okay, and you need to remember that another name for rate of change is slope. All right, so it says explain whether or not the table represents a function. All right, well, something's a function when the x values do not repeat. All right, so x values, okay, cannot, I repeat, cannot repeat. Okay, so again guys, that's a key concept. Okay, so if you see any x value repeat, then it's not a function. All right, so when I look at these x values, I see 2, 3, 4, 5. Did any of those numbers repeat? Did you see them twice? No. So that means this is a function. All right, so again guys, the aim is that the x values do not repeat. Okay, so let's look at this one. So it says again, explain whether or not the table represents a function. So again, we're looking if the x values repeat. Here we see 5, 4, 3, and another 4. So because we saw this 4 twice, that makes it not a function. Okay, so again guys, that's essentially the concept. All right, because what you're doing guys is that technically these are points that when you graph them, so again guys, when you graph them, 5, 4, that would be here, okay, approximately. 4, 2, that would be approximately about here. 4 for the x, 2 for the y. All right, 3, 0 would be 3 for the x, 0 for the y. All right, so that would be somewhere right here, okay. And 4, negative 2, 4 for the x, okay, so again 4 for the x, and negative 2 for the y will be somewhere down here. All right, so somewhere right here. Okay, so if you kind of connect those points together, that would look like this. Okay, and if you did your vertical line test, it would hit your graph. So again, if you did your vertical line test, it would hit your graph more than once. All right, so again guys, that's what it's saying. So what about the next question? So the next question says find the rate of change on the interval. So the find rate of change guys, you're looking at the change in your y values divided by the change in your x values. All right, so that change in y values is y2 minus y1, and the change in x values is x2 minus x1. You have to remember this formula because this formula is not given. All right, so we are given our x1 and our x2. So again, this is your first x value, this is your second x value. We need to find the y values that go with them. Okay, so what I'm going to do is that I'm going to plug in 4 into this equation to get that y value, because again, this function says f of x, and another name for f of x is y. All right, so I'm going to plug 4 in for all my x's. So I'd have parentheses squared minus 3 parentheses plus 2, and I'm going to plug in my 4. All right, so 4 squared is 16, negative 3 times 4 is negative 12, then plus 2. Negative 16, or rather positive 16 minus 12 is 4, 4 plus 2 is 6. All right, so that means we could set up a fraction. All right, and when we plugged in 4, that goes at the bottom, we got 6 as a result. It goes on top of it. All right, so now let's find our other y1. All right, so I'm going to plug in negative 2 into that same equation. So I'd have y equal parentheses squared minus 3 parentheses plus 2, and this time I'm going to plug in negative 2. All right, so negative 2 squared is positive 4, because anything squared is a positive number. All right, negative 3 times negative 2 is positive 6, then plus 2. 4 plus 6 is 10, 10 plus 2 is 12. All right, so again, based on my formula, there's a minus sign right here. And I normally try to put parentheses right here, guys. So I normally try to set it up like that, so it's easier for you guys to see whenever you have two negatives beside each other. So when we plugged in negative 2, that goes underneath at the bottom because it's your x. We got 12 as the result because that was my y. All right. So now I calculate. 6 minus 12 is negative 6. 4 minus negative 2. So here we see a negative beside a negative. So that's going to turn into a positive. So 4 plus 2 is 6. And negative 6 divided by 6 is negative 1. So the answer for the average rate of change is negative 1. All right. So let's do the same thing for the next question. So again, we're finding average rate of change, which is the change in your y values divided by the change in your x values, which is just y2 minus y1 over, x2 minus x1. Good job, guys. So we already... All right, guys. So as I said, we're going to now try to find the y values that go to these x values. This is your x1 because it's the first x value at the front. This is your x2 because it's the second x value. All right. So I'm going to rewrite this equation because we know that another name for f of x is y. So I have 4 minus parentheses squared. And inside of that parentheses, I'm going to plug in 3. Okay. So I would have 4 minus 3 squared, which is 9. All right. Or you could say 3 squared is 9. In front of here it's a negative 1. Negative 1 multiplied by 9 is negative 9. All right. And then 4 take away 9 is negative 5. Okay. So that means when we plugged in 3, so that goes at the bottom, we got negative 5 as the result. So that goes on top of it. All right. Now we put a minus sign, 2 sets of parentheses. Okay, now I'm going to find my other y value, so my y1. So I'm going to plug in, all right, negative 1 into my equation for y. So I have 4 minus parentheses squared, and I'm going to plug in negative 1. So I have 4 minus negative 1 squared is positive 1, or you could say negative 1 squared, and then in front of here is another negative 1, which will make it stay negative. All right? And 4 minus 1 is 3. So that means when I plugged in negative 1, that goes at the bottom. I got 3 as a result, that goes on top. All right? Now we calculate. Negative 5 minus 3 is negative 8. We see 3 minus negative 1, a negative beside a negative, so that turns into a positive. All right? So 3 plus 1 is 4, okay? Negative 8 divided by 4 is negative 2. And that is the average rate of change, all right? So let's do the next one, okay? So the next one says we're evaluating f of negative 4 for this function below, okay? So essentially, this negative 4 is replacing the x. So anywhere I see x in this equation, I'm going to write negative 4. So I'm going to have parentheses squared minus 12, all divided by 2. And then what are we plugging in? Negative 4. All right? Negative 4 squared is negative 4 times negative 4, which is positive 16. Then we rewrite the minus 12 all over 2. 16 minus 12 is 4. 4 divided by 2 is 2. And that is my result. All right? So what about the next one? So where I see x, I'm going to plug in negative 3. So I would have 2 parentheses minus parentheses squared, and I'm plugging in negative 3, all right? 2 multiplied by negative 3 is negative 6. Then we rewrite the minus sign, or you could say in front of here is a negative 1. Either one works. And then you calculate negative 9 squared, which is positive 9. Or you could say that in front of here is a negative 1. Negative 3 squared is positive 9. 9 multiplied by negative 1, negative 9. All right? And negative 6 minus 9 is negative 15. All right? So again, guys, just like that. So now final question. So final question says, write the factored form of a polynomial function with roots at x equal negative 4, x equal negative 2, and x equal 1. All right? So when we're doing this, guys, we need to remember that roots can give me my factored form by just flipping our signs. All right? So this first factor is going to be x plus 4. because to move a negative 4 to the other side, you would add 4 to both sides. So now we have our factor, okay? Our next factor, we would add 2 to both sides. So it would be x plus 2. And the next factor, we would subtract 1 on both sides, and then we would have x minus 1. And that is my factored form, all right? So again, because I had 3 roots, and another name for roots is x-intercepts. So again, another name for roots is x-intercepts, means that the y value would have been 0. And because these cancel out, that would mean the y value was 0. All right? And because we had 1, 2, 3 roots, that means we have 1, 2, 3 factors. All right? So here, we're doing the same thing, writing the factored form of the polynomial function. Here we have 1, 2, 3 roots. So that means we have 1, 2, 3 factored forms. All right? So my first one I would get by adding 2 to both sides. So that would be x plus 2. The second one I would get by subtracting 4 on both sides. That would be x minus 4. And then the third one I would get by subtracting 6 on both sides. So that would be x minus 6. All right? But what if you had a fourth factor, all right, or a fourth root? So say I said that your fourth root was x equals 0. All right? Can you add or subtract 0? No. So whenever you have a root that's x equals 0, that means the factor is just x. All right? So again, guys, that's something you need to be familiar with because we've seen it on other exemplars and on other previous EOCs. All right? So again, just like that.